Okay, join back. Uh, I think I was discussing about the problem that you are facing in the deletion in between. Okay, deletion at a particular location. So let me just go to now, at least the screen is visible. Please let me know from your end.
Yes, ma'am. Visible.
It's visible. Okay. Now I'll just run this program and try to insert from rear end initially. So let me have 10, 20, 30, 40 and 50 are the elements that are available. Now let me just display the contents. The elements are 10, 20, 30, 40 and 50. At this point, I want to delete the element from a given position. Okay, position from where element to be deleted. Say let me give 3 because Anushka had asked me to check for deletion of a node in between. Okay, so I have given 3. Let me check by displaying 10, 20, 40 and 50. 30 got deleted because I had given the position as 3. Anushka, it is working fine. Please check your code. Anyways, I'll be sharing all these programs to you today in your Google Classroom. So you can have a check at the thing that you have written and cross verify. Okay with that? Can I proceed ahead? जल्दी जल्दी कमेंट करो यार. Okay, thank you. Now I'll exit from this. Okay, and I'll go to. Okay, can anybody tell me what is the drawback of a single linked list? And anybody from your guessing, it may not be correct. See what you feel that it is not correct over here. What may be the drawback of single linked list? Yes, Srinivas has commented one comment. Let me read out that. Then somebody has unmuted. May I know who is speaking?
Only one link.
Yes, tell me.
Ma'am, it has only one link, ma'am. Doubly linked list.
It has only one link. Having only one link is a problem, or you have accessibility problem? What is the problem?
Accessibility, ma'am.
Yes, it is accessibility. It is not having a single link. Okay, so you cannot move in the reverse direction. This is a valid point pointed by Srinivas. Okay, even if you want to access last but one node, even when you are interested in accessing last but one node, even then I have to start from the first node and move up to the last node. Okay, so I have two solutions for it. Okay, I have two solutions for it. One solution is, okay, let me just check. There is one more comment given by Praveen. No random access and size of linked list becomes larger with each insertion. I'm not getting what is the point that you are telling, Praveen. Can you elaborate on this? No random access. Okay, random access is not possible as that of arrays. 100% correct. Size of linked list becomes larger with each insertion. This is also right. Okay, so two problems he has discussed. One is, unlike the arrays, singly linked list doesn't allow you to have a random access. See, in array, if I want to access 50th element in an array of 100 elements, I will access it with one go. I'll write a array of 50. I can have the accessibility to that. But whether that is possible in linked list, no. Searching always, I think Praveen, I have commented this before also. Searching when it is there, always arrays are much preferred. Okay, always arrays are much preferred whenever searching is there. But when you want to construct a data store, Here I am talking about construction of a data store. Okay, storage of data. When you are interested in constructing a storage of data, definitely you will not have any kind of restriction of adding only these many kind of values. So that restriction is avoided when you are trying to insert the nodes or delete the nodes. Insertion and deletion are happening more oftenly. If such case are there, then definitely linked lists are preferred. Definitely, when you are going for searching, you will be preferring, and anyone in the world will prefer what is called as an array. Okay. Now, having said this, I believe that now I'm creating a data store, and when I'm creating or updating the things, better I go for a dynamic kind of things, and that is called as linked list. Now, when I have a linked list which is called as a singly linked list, this singly linked list has a drawback. What is that drawback? I have to start from the last node and go up till the last first node, and I have to go up till the last node to reach the last node. So if in case I have 1,000 elements, I have to start from the first node and reach up to the last node. So there are two solutions for it. One solution is one straightforward solution. Instead of having access to the first node, I will have something called as address of the last node I will store and connect the last node back to the first node. I'll repeat it. Okay. Instead of telling, okay, look, I want to have the storage of first node, accessibility beginning at first node. Instead of that, what I will do is I will get every time the last node's address. Okay, last node's address I will store, and instead of writing null in the last node as the link part, I will have a link pointing back to the first node. This kind of linked list, singly linked list I'm talking about, this kind of singly linked list is called as circular singly linked list. How does it look? All of you please write it down in the paper that you have in front of you. Okay. If I have the elements like this, 10, 20, 30, 40. Now, if you want to mark the links among these nodes, how do you link if it is a case of singly linked list? You will do like this. 10 is pointed by first. Guys, I'm not writing it purposely. You have to analyze on the paper. Okay. 10, 20, 30 and 40 are the elements that are available. Now, if it is a singly linked list, you will write first pointing to 10, then 10 to 20, 20 to 30, 30 to 40, and 40 is followed by a null. Okay, this is what? This is a simple example of singly linked list. Now I want to overcome the drawback. What is that drawback? Even if I want the last node's value, I have to start from the first node. That is a drawback. Okay, so what I will do, instead of storing the first node's address, please write down 10, 20, 30, 40 again. Again. Have you written down? Don't link anything. Have you written down? Yes. Now what you do, at 40, you just give a pointer and mark that as last. Mark that as last. And now add the links from 10 to 20, 20 to 30, 30 to 40, and 40 to back to 10. So what does it mean? It means the circular queue that I was speaking about. Okay, where the two ends are wrapped around. The two ends are wrapped around. So when I tell 10, 20, 30 and 40 are linked together and I have a pointer to the last node in turn points back to the first node. This is an improvisation, simple improvisation to the plain singly linked list. What is the advantage of this? Can anybody comment on this? What may be the advantage of doing this modification? Of course, reverse searching will not be possible. Definitely, it holds good. What may be the drawback? What may be the advantage of this modification? Yes, I'm waiting for your answers. Any guessing from your end? Time consumption in traversal for elements at last or after the mid becomes low. Okay, Praveen, halfway it is correct. Okay, see, you just tell me how many iterations are required to reach 40 in the given example. 10, 20, 30, 40 is a given example. If you want to reach 40, how many iterations are required to reach 40? How you will search for an element? 3, 3 or 4? 3 or 4? 3. Current will be at 10. Current arrow info checked against the key element to be searched. Okay. 10 not equal to 40 goes next. 20 checked against 40 goes next. 30 checked against 40 goes next. So 4 iterations. Okay. 3 iterations are required. Okay. So if I have a pointer to the last node, the second case that you have drawn, if I have a pointer to the last node and being at the last node address, if I want to have the accessibility to the last node, how many iterations are required? Or do I require any iteration of the loop? 0. If I want to have accessibility to the first node, how many iterations are required? 1 it is. Why? It is just because last node immediately has got connected to the first node. So if I write last arrow link, what is the meaning of it? Last arrow link is nothing but what? It is the first node. So having done this kind of simple modification, instead of having accessibility to the first node, what I will do is I will restore the address of the last node. Okay, and wrapping around the last node with the first node. Having done this, what is the advantage that I am getting? With a lesser number of iterations, I will have the accessibility to both the ends of the linked list. Of course, I cannot go back. I cannot have the accessibility in the backward direction. Okay, so this is called as circular singly linked list. We will take up the circular list a bit later. Okay, now what I will do, I will do one more addition to this. I don't want this last node. I want to continue the way I have done previously. Okay, but I will stick on to the problem that is associated in the single linked list. The problem that is associated is I cannot traverse backwards. I cannot traverse backwards. So this drawback, how I can come out? I can come out by adding one extra pointer between two nodes. What is that extra pointer meaning? The extra pointer talking about one pointer moving from the current node to the next node and another pointer moving from the next node to the current node. So what does it mean? Every node will look like left info right. I will repeat again. Every node will look like. Now can you draw the simple structure of singly linked list node? How a singly linked list node looks like? Can anybody quickly comment? What is the content of singly linked list node? How many parts it has? Info and link, only 2 parts. Okay. Now if I want to have a modification done to this, every node must know who is available next to it and who is available previous to it. It means what? Every node must know who is the future, who is the past. Okay, so this kind of modification, if I want to do, I have to structurally modify the node. And the structural modification that I need to do is add one more counterpart as part of the member of the node. And it looks like this. There has to be a left, there has to be info part, and there has to be right. Left will store the address of the previous node, right will store the address of the next node. If left is null, it means that the node that you are speaking right now is the first ever node. If the right part is null, it means that, okay, there is a comment, please let me read. Ma'am, are you typing anything on the screen? I'm not typing anything, Suman. Purposely, I'm not typing because you just have to imagine all these things. Okay. If you want me to draw it, I'll draw it and show it to you. Not an issue for me. Okay, just wait. Please wait. Okay, my doubly list would look like this. Whether the screen is visible, please comment. Yes, thank you. Now, what I will do is I'll call this as a doubly linked list node. How these things will have. There is a left part, there is an info part, and there is a right part. What is each part doing? Left part is an address of previous node. Okay. Info part is current node's value. What is right part? It is address of next node. Are you all okay with this explanation? So my doubly list will always look like this. A node of a doubly list will look like this because every node must know who is its predecessor and who is its successor. Who is its successor is known by the address. Who is its predecessor is known by the address. So both of them are nothing but self-referential structure members. What is the meaning of self-referential structure? A structure having a member which is pointing to itself of its own type. So there is a pointer pointing to its own type. That kind of structure will be a node's structure. So how many self-referential pointers are there? Two. One acting as left, who is pointing to the left node, and there is acting as a right, who is pointing to the right node. The successor and the predecessor. At the center, I will have the current node's value. So every node would store one extra thing. One extra thing costs a lot actually. Every time you want to store a new node, you need to bother about 4 connections. How 4 connections? Can anybody comment? How 4 connections I have to bother about? You just imagine like this. You have 10, 20, 30, 40. Please draw it all of you guys. Draw it all of you. You just write down this. What is that you are supposed to write down? 10, 20, 30, 40. Okay, let me just draw it. 10, 20, 30 and a 40. Okay, if it is a singly linked list, there will be a connection from 10 to 20. Okay, then there is a connection from 20 to 30. Then there is a connection from 30 to 40. It's as simple as that. And 40 will be ended by a null. Okay. Now what I have an addition. What is that addition I'm talking about? When I talk about an addition here, I will be talking about, just 1 minute guys. Okay. Now I will be talking about a linkage of backwards also. How does it look like? 10 is connected to 20. In turn, 20 has to be connected to 10. Similarly, the 20 is connected to 30. Similarly, 30 has to be connected to 20. And 40 to 30, there has to be a connection. So every pair of nodes have in total 2 nodes in between both of them. Now, if I try to insert 35, okay, if I try to insert 35, where according to me 35 has to come in between 30 and 40. Okay, let me take 25. Now, if I want to add 25 between 20 and 30, if I am suppose I'm creating an ordered list, 25 has to be added. How many pointer adjustment I have to do? Can you guess from your end? 4? 4? Okay. How there are 4? Let me just show you by doing it. Okay. First thing that I'm doing is I'm connecting the right part of 25 to 30. Okay, and left part of 30 I have to connect to 25. This is the first modification. Okay, so this link goes off. 30 back to 20 goes off. That is overwritten by 30 back to 25. Now what I will do, 25 has to be, left part of 25 has to be connected to 20, and 20's right has to be connected to 25, and this also goes off. So every node insertion, in between node insertion, will require 4 pointer adjustments, which is very much costly, which is pretty much costly. So if you don't have an affair of adding in between elements, then definitely who is useful for you? Doubly linked list. But if you have more number of insertions in between, definitely it will cost you a lot. So please be careful in choosing the right data structure based on the application that is given to you. Okay. Now let's assume like this. For every insertion of a node in between, I require 4 pointer adjustment. Okay. Now at this point, I have 10, 20, 25. Again, pardon me for my handwriting. 30 and 40. Okay. Now every node pair has 2 links, as you have seen. 2 links. Okay. At this point, I want to delete a node. Suppose I want to delete 25. How many adjustments, pointer adjustments have to be done? Fatafat. How many pointer adjustments have to be done in order to incorporate delete operation in between? If I suppose want to delete this 25, how many modifications of pointers required? Is it 2 or 4? Please cross verify it. Look at this. I have to remove this link and add it to 30. Right of 20 should be pointing to 30. Okay, right of 20 should be pointing to 30. Okay, then left of 30 has to be disconnected and added to 20. You are right. There are 2 modifications required. And when I free this node, definitely the left part of 25 will go off, right part of 25 also will go off. So there are 2 more pointer modifications if you want to delete a node in between. Okay, it's actually double the number of modifications that you do in single linked list, but it has an added advantage of searching forward as well as backward. So when you want to search for a node, for an element in a linked list data structure, who is preferred? Doubly linked list is preferred because you can either go from first to last or last to first. Suppose that you add, instead of first node, you add a last node and have a pointer from last back to the first and first back to the last. You just imagine like this. Guys, you please imagine like this. I will discard this. and I will restart this. Okay, just imagine like this. I just want to have a modification done like this. Please pay attention. Instead of storing first, this I have discussed in circular list. Okay, I will store the last pointer's address. Now what I will do, I will assign the right part of 40 to the first node and first node's left part back to the last node. Okay, so this kind of modification, it is called as circular doubly linked list. This serves all the purpose. What is that? You can have with a single access, you can have both last as well as first node with a single point of accessing. And at given any point in time, you can traverse either backward or forward based on the situation. So all the disadvantages of singly linked list are overcome by circular doubly linked list. But this has a drawback. What is the drawback? What may be the drawback? You can guesswork. Flexibility is more here, but you have a drawback. What may be the drawback? Declaration of more pointers. More than that, any movement or any kind of addition or deletion, it requires a lot many pointer adjustments. That's the drawback. Okay, so if your application doesn't include more number of deletions, definitely you go for what is called as circular doubly linked list. Okay, leave all these things. Today we will be discussing about simple modification of having both end traversals. Okay, either you can move from first to the last or last to the first in the backward or the forward direction. I will be going through what is called as doubly linked list. Then we will discuss about what is called as circular doubly linked list. Okay, now I will just open the program that we have discussed for singly linked list. Guys, you be very careful. Okay, now you know that how a doubly linked list looks like, and every operation that we have written for singly linked list, you should be able to modify it for doubly linked list. One after the other, the functions I will take. Okay, guys, I need your involvement for writing these programs because now you are okay or thorough with how to use the pointers in writing singly linked list program. Okay, please involve yourself and pay attention, and you have to comment what is the modification that I need to do. All fine? Can I begin? Jaldi se comment karo. Shall I begin? Yes. So I have simply copied and pasted the singly linked list program. Nothing else I have done. I have not done even a single, okay, I'm sorry, I have done this modification. I have changed SLL to DLL, but otherwise in the program, I have not even done a single change. Okay, changes you have to tell me. So what should be the node structure for doubly linked list? Let me just change this comment. Okay. Now, what should be the modification for the node of a doubly linked list? No comments from your end? How a doubly linked list look like? If I go back, how a linked list look like? Doubly linked list. Left info right. So what should be the modification that I need to do? I should have right as well as left link. Correct. So int info, I will keep it as it is. Then I will write struct node star left, and let me write struct node star right. See guys, you can very well write comma star right here, not an issue. Okay, but purposely I have written them separately in order to show explicitly two self-referential structures are there. Okay. So any other modification in the node, or can I go ahead next? Is it okay? This is a node of the doubly linked list. Type yes if it is yes. Yes. Now I'll go ahead. So I will type define it. This holds the same thing, no change at all. Okay. Struct node now will have three parts in it: info, left and right. Okay. If you want to write it in the format in which it looks, let me write it like that only. Okay. Struct node star left, then info, then right. Now is it all right? Sorry, I think I have deleted a line. Just 1 minute. Okay. Now, after this, I have type defined struct node as capital NODE. Now, struct node star create node. This holds the same thing. Can you tell me when create node function is called? In what operation? What kind of operation create node is called? Only in terms of insertion, correct? In case of insertions, always the create node is called. So can I complicate this create node in such a way that every time the create node is called, it creates automatically the pointer, and ptr arrow left is equal to null, ptr arrow right is equal to null, ptr arrow info is equal to the element. You can very well rewrite this create node. Okay, but let me keep it as it is. Does it alter? Anything alters here? Please let me know from your end. Any alteration need to be done in the create node? So when I write struct node star ptr, this ptr is pointing to a doubly linked list node automatically, because what I have changed? I have changed the definition of struct node. Okay. Now when I write size of struct node, it will give me the size of a node containing three parts: left, info, right. So that size only will be passed. So what is that you have modified? You have only modified the structures definition. It will be incorporated everywhere. This is how global declaration helps. Where structure is defined? Structure is defined before the main. It is not part of any function. This is called as global scope or global declaration. When you do modifications in the globally declared thing, everything gets modified that follows. Everywhere, in every occurrence of it, the modification will be applicable. Okay. So is there any change required in create node? Yes or no? Type it according to that. Any modification required? No. What about others? No modifications required. Only two people. What about others? What do you feel? Modifications required or not required? Think and answer. Don't simply tell. How about others, guys? Are you all going to sleep, or you are active, or you are not understanding whether to tell yes or no? Always see, in any kind of voting system, okay, those who stand in between, no, they are very dangerous, because who wins, no, that side they will take. That's very dangerous part that you are doing. Guys, I will repeat what I have told. When I write struct node, now this node is nothing but what? A doubly linked list node, because it would have taken the definition of the node that I have given as a global thing. Globally, what I have done, I have declared this structure, and this node is now containing three members: left, info, and right. Definitely, create node, whenever I call this struct node star, it would be taking with reference to doubly linked list node only. So there is no change required for the create node function. It remains as it is. Remains as it is. I hope I'm clear with the explanation. So let's proceed ahead. Now, function to insert at the rear end of the singly linked list. Okay. Now I'll just take an example like this. Please pay attention, all of you. I have taken an example like this. 10, 20. You please assume this minus is nothing but doubly list. So both sides it is. Okay. Or let me just show it like this. What is the meaning of this? It is doubly list. Now you just assume like this. Okay. So let's suppose this is right now available list. Okay. Now if I want to have insertion at the rear end, what is that you are trying to do? Insert at the rear end. Let's assume I have to insert an element 50 at the rear end of the list. So what is that you are doing? First thing, 10 is pointed by what? 10 is pointed by first. Okay, 10 is pointed by first. Let me run the slideshow, please. Okay, 10 is pointed by first. Now, what I will do, I will take one extra pointer current who will be pointing to the first node. I will make this current until I reach the last node. Similar to singly linked list. In singly linked list, I had written until current arrow link not equal to null. What I will do? I'll write current equal to current arrow link. What should be the modification to that part of code? If I want to reach the next node in the doubly linked list, how do I reach from this node to this node? Which is the link that I am referring when I am moving from 10 to 20? Right pointer. So when I write current is equal to current arrow right. So what I will write? While current arrow right not equal to null. Okay, while current arrow right not equal to null, what I will do? I'll write current equal to current arrow right. I'll just go back to the program. Okay, just pay attention to this. These things I'll take it later. Current is equal to first. Then, while current arrow link not equal to null I have written. Instead of that, now what I will write? Current arrow right not equal to null. Until that time, I'll do current is equal to current arrow right. So you are moving in the forward direction. If you want to move in the left direction or in the backward direction from the last node to the first node, you will write while current arrow left not equal to null, current is equal to current arrow left. Then at that point, you are starting from the last node. Whether this is clear or not, please let me know. A big request from my end, whether this part is clear or not. Comment jaldi, please. We have lot of things to do. You have understood this. Now, at this point, what all may be the modifications that I need to do? I am right now in line number 52. What is the modification that I need to do? Jaldi bolo. Definitely, I would require the address of the first node, then I would require the element that needs to be inserted. So this part remains the same. This part remains the same. Okay. 52, 51, 52, 53 line remains the same. After this, what is the modification that I need to do? I'll give you 2 minutes of time. Not 2 minutes, you require 1 minute. Okay, all of you are right. So how I should write? Whatever you have told, I am typing. Okay. If any error, it is your responsibility. Now, temp arrow left is equal to, let me write temp arrow right is equal to null. So both the left as well as right pointers are pointing to null. It means what? I have created an independent node which contains E as the info, left as null, right as null. All of you are 100% correct. When? Well, whether this condition is correct or any modification required. If correct, please type correct. It will work fine for doubly linked list also. Yes, you are right. Now I will go back to line number 61. Okay. Current is equal to first. This is as usual. Okay. If I do not have empty list, it means there are elements in the linked list. At that point, what I will do, I will assign current to the first. Now, this condition we have already discussed. While current arrow right not equal to null, current equal to current arrow right. After this, can you tell me the modifications? I am just laughing like anything, guys. Okay, because at this point you have to govern the program. You have to govern the program at this point. Okay, tell me what should be the modification that I need to do at line number 66. You have half a minute of time. See, by the end of the while loop, you would be making current to point to the last node. Okay. So next, what I need to do? Okay, I'll give you time for typing. I'm so sorry for that. Okay, I've got few comments. I want everybody to think about it and then I will start editing. See, every time you have to think in 2 dimensions here. 2 directions you have to think about. What about others? Ashita, please think about it. Okay, temp arrow left. Okay, you have commented previously also. Let me just check. Yes, you're right. Okay, you have commented 2 times. Yes, what about others? Please comment it. Okay, Aditi, current arrow right equal to temp. Is it enough if I do like that? You should think in 2 directions. Okay, so temp arrow right is equal to null, already done. Who has commented this? Varsha. Varsha, temp arrow right is equal to null, already done. So you don't require that. Okay. So let me sum up whatever you have typed. Let me sum up that. Current is right now at the last node. Current is right now at the last node. Okay. Now this is your temporary node. Current is at the last node. Current arrow right must be pointing to the temp. Temp arrow left must be pointing to the current. These 2 modifications I have to do. So accordingly, let me write the current arrow right equal to temp, then temp arrow left equal to current. Then return first. Now, is this correct? Is this the correct function that is required for the insertion at the rear end? Just have a glance through this function. What is that I have done? I have created a node. I've created a node and assigned the element as the info part, left and right part of the temporary node made as null. I have checked whether the first is pointing to null. If it is pointing to null, I will assume that there are no nodes at at this point in time. So I will make the temporary node itself as the new first node. Then otherwise, I will assign current to the first and I will scan through the linked list until I reach the last node. And once I have reached the last node, I will assign currents right to temp and temps left to current. Then return the first. It's 100% correct and it's a working function for insertion at the rear end. Okay, guys, you just have to complete. Today I'll be sharing this program to you. You just have to complete insert front, delete rear, delete front according to this. Can you do it for today? Comment quickly. I'll repeat. Insert front, delete rear, delete front. Okay. So shall we end the class for now? Actually, guys, more than you, my neighbors are telling me to end the class. Okay. Okay, there is a question. Is the size of pointer fixed according to architecture? Definitely. Pointer size is nothing but address. Address size always remains the same. Praveen. Pointer size never will vary because its data type is fixed. Yes, it is 4 bytes. Okay. So we will end for now. Thank you all. Tomorrow we will begin with the further discussion of doubly linked list. Thank you. Praveen, can you ask this question tomorrow again? Okay. Size of varies from compiler to compiler. Definitely it will give different answers. Don't try it in multiple compilers. It will give different answers. You ask this question again tomorrow so that everybody will get to know about it. Okay? Yes. Thank you.